this demo, I'm gonna show you how ocean circulation forms. And also, I'm gonna show you a very unique water wave that you have never seen until now. Alright, let's get started. So what I have here is a water tank that is divided into two smaller water tanks. On the left, the blue water is cold, dense water. On the right, the red water is hot and less dense water. I want you to observe what will happen once I take the divider out, especially what happens in the middle and what happens at the surface. You see the waves in the middle? A quite big wave across the entire tank. But the surface is very calm actually. So basically we can observe three things. First of all, the blue water goes on the bottom and the red water goes on the top. This is no surprising because the blue water is heavier. Second of all, we're able to see some waves in the middle of the water, but not at the surface, which is kind of strange, right? The waves we're looking at in this demo is actually a very special type of wave that's called internal gravity wave. I'm gonna explain this a bit more later. And third of all, we're able to see some mixing in the middle between the blue water and red water, and that creates a middle layer that's purple. And you are able to see this purple layer a bit more obvious later. So let's put the divider back and mix the water on the left. You can see the blue cold water and red hot water mixed into warm purple water. Now I'm gonna take the divider out again. What do you think will happen? Take a guess. Let's do this. So what we're looking at are two internal gravity waves. One at the boundary between the red water and the purple water. The other one at the boundary between the blue water and the purple water. Also, you are able to see the purple layer becomes thicker because more mixing happened. Now, let's talk about how this demo can show us how ocean circulations are formed. I will also briefly touch on the dynamics of internal gravity wave. So the blue water represents the cold, dense water at the polar region, and the red water represents the warm, less dense water at the equator. The cold, dense blue water will sink to the bottom and then will head towards the equator. This is due to the law of conservation of mass. Since the water cannot get just piled up at the bottom, it has to go somewhere, and the only place to go is towards the equator. And due to this sinking current at the pole, there's going to be a gap left at the surface of the pole, which will immediately be filled by the current coming from the equator. And this current coming from the equator will in turn leave a gap at the surface of the equator, which again, due to the law of conservation of mass, has to be filled, and it's going to be filled by the water coming from the bottom of the ocean, and this completes the entire cycle and the pattern repeats. By the way, this current coming from the bottom of the ocean to the top is what we call upwelling current. It is very rich in nutrients because it comes from the seafloor, which has a lot of sediments and debris of organic matters like dead planktons. So it is really rich in nutrients, and that's why we build fish farms where the upwelling current is. Like the largest fish farm in the world is located at the coastal area of Peru, which is right on top of this upwelling current. So, to sum up, to have circulation, you need at least two bodies of water with different density. The technical term is called stratification or stratified fluid. So if you have stratification in the ocean, that means you have different layers of water with different densities, and that situation has the potential of turning the water. In fact, for this demo, instead of using cold hot water, you can also use salt and fresh water to generate the density difference. And the stratification also ties into the generation of internal gravity wave that we're going to talk about next. So I'm going to give you a very visual representation of internal gravity wave. Imagine there's a red water ball in the red water and blue water ball in the blue water. And initially there may be some disturbance that caused both water balls to go down. However, since the red water ball is lighter, it has a smaller density, it's not going to stay in the blue water environment, it's going to float. So both water balls will actually come up. And due to inertia, now the water balls have some sort of velocity. They won't be just staying there, and due to inertia, they will actually keep going up. And now the blue water is in the red water environment. And remember, the blue water is heavier, it has greater density. It won't be able to stay in the red water environment, so the blue water will actually come back down. And again, due to inertia, it now has some velocity and it'll keep going. So eventually, the red water ball comes back to the blue water environment again. So this is the same as the second stage we have shown on the graph, right? And that just means this pattern will keep repeating itself. And you are able to observe the wave pattern on the graph right now, since the water balls are going up and down. And if we put those stop motions pictures together into a continuous motion, and it'll look something like this. And it'll just keep repeating itself until the energy is lost to resistance. So what are some applications of internal gravity wave, or where do you encounter internal gravity wave? If you have ever gone sailing in a estuary area, by the way, estuary is where river meets the ocean, and you will have a stratification situation there. Since the river is fresh water, it will go on top of the ocean water, which is salt water. And if you're sailing in here, let's say this is the boat, and the boat will cause some disturbance in the water, just like the disturbance in our water tank, which in this stratification situation will generate internal gravity wave. The wave is really powerful and can exert a resistant force on the boat, and that will cause the boat to slow down, or sometimes even just trapped in the water, which we call the dead water effect. Hope you enjoyed the video, and check out my YouTube channel for more videos like this.